Hello, everyone. Greetings of the day. The authors and invited guests, welcome to Technical Session 7E. Myself, Prashi, and this session would be moderated by me. On behalf of Global Knowledge Research Foundation and GS Scholastics, it is my great pleasure to welcome you to the 11th International Conference on Information and Communication Technology for Intelligent Systems, ICTIS 2026, Bangkok, Thailand. The 11th edition of this conference is being organized in a hybrid mode. The physical event will be held tomorrow in Bangkok, Thailand, and the virtual event is being held through Zoom from 9th to 11th of April 2026. I hope you will enjoy the knowledgeable and interactive session through the day. In this session, we have 10 presentations. Each presenter will be given 10 minutes for the presentations and 2 minutes for question and answers. On the 9th minute, I will be raising a gentle reminder. There is another request to all the participants that you stay connected with us till the closing remarks. If you have any queries or any updates, then you can write it to me in the chat box given down below. And just before we start our session, I would like to introduce you all to our session chairs for this session. Professor Hector Rafael Minoro Okono. Professor Hector is a professor in the School of Engineering and Science at Monterrey Institute of Technology and Higher Education, Mexico. With over 16 years of experience in higher education, he specializes in mechanical engineering, robotics, and educational innovation. His research focuses on product lifecycle management, PLM, AI in engineering, cyber physical systems, and education 4.0. Sir, we welcome you to the session. Would you like to say a few words before we start our session today?
Yes, sure. Thank you very much. Welcome, everyone. It's a pleasure to be with you. As previously mentioned, this is technical session number 7E. I want to thank you for being here. I'm sure it will be a very productive session. So thank you again. Welcome.
Thank you so much, sir. Now, I would like to introduce you all to our second session chair for this session, Professor Debraj Chatterjee. Professor Debraj Chatterjee is an assistant professor in the Department of Computer Science and Engineering at Techno International, New Town, West Bengal, India. He has published numerous research papers across international journals, conferences, and book chapters. His research interests include computer vision, deep learning, and software engineering, contributing to his strong academic and research profile. We welcome you to the session, sir.
Hi,
Before
good morning.
Yes,
Good morning, Prashi.
Good morning, sir.
Yeah, it's been a good morning for all the candidates also for going through all these different sessions that are given for them. Thank you very much for inviting me here.
Thank you so much, sir. Thank you so much for being here with us. Okay, now that we have introduced our session chairs to you all, I would like to call upon our first presenter for this session. Our first presenter is Hassan Ahmed, presenting a paper on the title, A Literature Review on Fog Computing in Supply Chain Management, Enhancing Efficiency, Security, and Scalability. Sir, I request you to kindly take over with your presentation.
Good morning, everyone. Thank you so much, Prashi, for giving me the dais to speak and present my work. I'll be quickly putting up my file. So, have you transferred the sharing rights to me?
Yes, yes.
Is my screen visible to everyone?
Yes, sir, it is visible, sir.
Okay, thank you so much. So the title of my work is Fog Computing in Supply Chain Management, and I have studied the efficiency, scalability, security of using fog computing while managing supply chain management across borders, across study, across various businesses, especially in logistics. I am presently a PhD scholar under Professor Ram Singh at the Indian Institute of Foreign Trade, New Delhi. As such, I am a working professional in the Government of India also working for the custom side. Thank you so much, everyone. Here I go ahead. The problem statement which I underwent was that the cloud only supply chain management suffers from high latency, Internet of Things, data volumes, they overwhelm centralized architectures, real time supply chain decisions are often delayed, choked, resource scheduling lacks QoS aware prioritization, security risks increase with the centralized data stores. So here we propose that should not we use priority scheduling of fog computing services which optimize the quality of service in the globally integrated supply chains. The motivation coming from the Internet of Things driven supply chain, which they generate massive edge data, latency sensitive tasks need sub-second responses. Fog computing brings computation closer to sources. Priority scheduling ensures critical task limits. Task first, global trade demands are scalable and they actually desire secure SCM solution. So if we mix up, if we rightly blend up the fog computing with the priority scheduling, then what we get is the quality of service optimized supply chain operations for the movement of goods. We underwent a literature survey. We came to observe that there's a research gap. We can have a quick look at the research gap that there's a limited integration of priority scheduling of fog computing services with the present SCM workflows, though the study has started in bits and pieces, but yet to get implemented, yet to be get adapted and adopted by the businesses worldwide. The security aspects are not sufficiently addressed in the fog SCM. Then there's no unified integrated QoS evaluation across scheduling types. Scalability remains untested in the emerging market areas. They're also not thoroughly tested in the developed markets as well. The AI ML scheduling methods are yet to take off. They are not presently benchmarked for the supply chain management. The gap summary, if we could say, it is like no comprehensive review which thoroughly covers the priority scheduling aspect of fog computing while integrating it into the global or the local supply chain management or addressing it fully in through the cybersecurity and the technological neutrality challenges. The objectives of our study: reviewing the PSFCS algorithms, heuristic based, machine learning based, hybrid based, analyzing QoS matrix. The most prominent matrix which we should be paying attention is the latency thing, the bandwidth, the reliability, evaluating fog SCM integration across industry domains, identification of cybersecurity and technological neutrality issues, proposing a future research agenda for fog-enabled SCM. Here we go. The key contributions, if we could summarize, is like comprehensive taxonomy study, definitions, and the framework for PSFCS scheduling algorithms, multidimensional QoS comparison across various methods, the SCM specific analysis, smart grids, agriculture, IoT integration, security and neutrality perspective for the global trade, future agenda. If we could look into the AI ML integration, look into the exact peculiar and pedantic problems of the emerging markets while also addressing issues of ethics. The novelty of this paper being the first review bridging and discussing PSFCS scheduling, SCM applications, cybersecurity, and technological neutrality in a unified, integrated framework. So the literature review, the prominent literature which have been reviewed in this work is Banerjee, Bhaiya and Sri Rama, Hosseini, Islam and Kumar, Gupta and Singh, Musa and Vidyashankar. As we see, the five prominent prominent criteria which we undertook and we studied, we went through their theoretical contributions And what they have delved into is like first one is scheduling, the second one is the SCM thing, third one is the security, the fourth one is the quality of service, while the fifth one is the scalability. So what we have done is that we try to study it wholesomely, and our review covers all the five the aforesaid criteria. So the framework continues to go into the algorithmic taxonomy, QoS analysis, SCM integration, security layers, and the future agenda. The algorithmic taxonomy, it covers the heuristic algorithms. The most prominent ones for priority scheduling is like the first come first serve, round robin, as well as the shorted job next. And when it comes to the ML, the machine learning AI algorithms, we get to see whether the approaches like the neural networks or the reinforcement learning, they are able to give us results in real time for the challenges which get faced in the SCM implementation. Then the QoS analysis, we have covered the latency, bandwidth, reliability, availability. We have looked into the application into smart grids, agriculture, logistics, primary focus being logistics, security layers, blockchain, data privacy, fault tolerance that can be integrated as a layer. The future agenda could be getting long haul with integration of AI, ML. Then if we could address the particular problems of the emerging markets as well as ethics in terms of privacy, ethics in terms of data sharing, ethics in terms of disposal of the used data, ethics in terms of the analysis of the used data. Then a very common, a very regular objective, and the equation which we see that this gets to with deeply integrate the various parameters as we have put it in the equation form, the priority scheduling objective. So this is a very simple proposed architecture wherein the fog nodes, they try to lessen the load in the cloud data center, as well as they try to maximize the desirable parameters as we have discussed aforesaid. So this is again a simplified proposal for integrating of PSFCS scheduling workflow. The tasks arrive at the IoT, priority classification is done, then we see whether the fog resources are needed. If they're not needed, the tasks can be offloaded to the cloud. If they're needed, yes, they can be allocated to the nearest fog node while carefully paying attention to the parameters, executing and monitoring the QoS. Then this is how the results are managed, then again put to the cloud or given to the fog nodes. The evaluation framework, we reviewed 23 peer-reviewed studies belonging to Springer, Elsevier. We got through the heuristic ML hybrid methods. The QoS metrics which we have analyzed is latency, bandwidth efficiency, reliability and fault tolerance, scalability under varying loads. So evaluation dimensions have been mentioned as the cross as the result of the algorithmic type, the QoS metric, the SCM domain, security mechanism, as well as the scalability. This is our comparative result. It's a theoretical study. We have not so far indulged into any data capture or data analysis. So what we have done is only picked up our study, our analysis from the papers which are already there in the domain. So as we could see, the hybrid genetic algorithm approaches, they achieve up to 2.5 times the better QoS than the traditional first come first serve algorithms. The smart grids, they're all real time SCM, low latency medical supply chains in the healthcare, agricultural IoT, agricultural area, IoT-driven rural logistics can be addressed. Manufacturing, AR, VR, enhanced warehousing, global trade, blockchain, secured operations can also be handled. And they're very useful and transformative for the economy, for the emerging economies. As we come to the conclusion, comprehensive review is what we have studied. We also propose to include the hybrid ML scheduling practices for a superior QS performance. Security and technological neutrality, they are critical gaps which we seek to address. And in the future, as we go ahead, the AI augmented fog scheduling is what we are looking at for autonomous, self-sufficient, self-learning SCM models, while also integrating blockchain integration for secure supply chains. And empirical studies are possible in emerging markets like Southeast Asia, India, and South Asia. Thank you so much, everyone. My presentation is what has come to an end.
Thank you so much, sir. I would like to invite our session chairs if we have any questions for Sir Hassan.
Yes, sure. Thank you. Thank you for your presentation.
Thank you, sir.
Now, if we want to use this framework in other areas, for example, how could this framework be adapted to detect misinformation in real-time social media streams or perhaps in multilingual environments?
Yeah, in social media streams, sir, whatever data is not immediately needed to be is not immediately needed to be stored, they can be processed locally, sir. Because a lot of social media streams, they are not very relevant in terms of traveling all the way to the cloud centers. However, it will have to be looked into as to the definition of what is important and what is not. However, in terms of the government regulation, the government regulating social media, this framework architecture could be very useful, sir, in terms of what actually travels all through and what gets processed and quite quietly checked by the fog nodes.
Okay, thank you.
Thank you, sir.
I want to ask one question to Hisham, sir. Good morning, sir.
Please, sir. Please, sir.
So the question is, you have gone for the future research detection that we want to use for autonomous SCM. So how we want to implement that?
In the sense that if we have some implementation models which can be applied for a small business, and then we see whether the SCM model which is integrated with AI would be self-sustaining while using the methods of reinforcement learning of ML, we could see whether that can be scaled up, sir.
Okay. Thank you.
Thank you so much, sir.
Thank you so much, sir, for your presentation.
Thank you so much.
Now I would like to call upon our next presenter for this session. Our next presenter is Gagani Kulathikalaka, presenting a paper on the title, A Zero-Shot Cross-Patient Transfer Framework for Seizure Forecasting via the Strict Principle of Protocol. I request you to kindly take over with your presentation, please. Ma'am Gagani.
Thank you. Wait a minute. I'll share my screen. I hope my screen is visible.
Yes, ma'am, it is visible.
Okay. Good morning, everyone. My name is Gagani Kulathikalaka, and today I'm presenting our research on a zero-shot cross-patient transfer framework for continuous seizure forecasting. This work was conducted alongside my co-authors at the Informatic Institute of Technology, Colombo, Sri Lanka. The biggest hurdle in deploying wearable seizure monitors today is the cold start problem. Deep learning models are highly accurate, but they currently require patient-specific training. This means a new patient admitted to a hospital has to wait days or weeks for the system to record multiple seizures before it actually starts predicting them. Our goal was to eliminate this waiting period entirely and achieve a zero-shot out-of-box operational capacity. Why is zero-shot forecasting so difficult? It comes down to covariate shift. Every human brain is anatomically different, and hardware like electrode impedance varies. If you take a generalized model and deploy it on a new patient, the model will often make the patient's unique baseline brain activities for a pre-ICTIS stage. This triggers endless false alarms, causing alarm fatigue for doctors and rendering the system unusable. To solve this, we designed a zero-shot cross-patient transfer framework. It is an end-to-end pipeline containing two main parts, a horizon-aware graph transformer for extracting features, and a novel strict discipline protocol for domain adaptation. The key advantage here is absolute interpretability. Our system requires zero gradient updates or retraining on the target patient to function. For the base architecture, we use the horizon-aware graph transformer. It is a graph attention network to map the brain spatially, treating electrodes as verticals and neural synchronization as attention edges. Simultaneously, a ResNet 1D tracks how the signal degrades over time. Together, this model creates highly expressive representations of the EEG data, acting as a powerful foundation for detecting universal seizure precautions. This is our core innovation, the strict discipline protocol. Standard domain adaptation is too computationally heavy for wearable devices. Instead, during pre-training, our network learns the global mean and variance of brain activity across many patients. When deployed, we completely freeze the network. We mathematically prescale the incoming data of the new patient against this global baseline. This forces the patient's unique biological noise to fit into the network's known parameters. Practically, how is this deployed? When attached to a new patient, the system enters a 10-minute calibration phase. It just passively listens to the patient's normal brain waves to calculate their local baseline statistics. Once those 10 minutes are up, the system immediately shifts into active inference, pushing data through the frozen network in milliseconds to output continuous time to seizure countdowns. To validate this, we use the benchmark CHP MIT dataset. To strictly simulate a patient walking into a hospital for the first time, we use leave one out cross-validation. If there are 22 patients, we train on 21 and test on the 22nd. Most importantly, the model has absolute zero access to the 22nd patient's seizure history or clinical labels before forecasting begins. Our system introduces a clinical metric, time to utility. Traditional models takes weeks to become useful. Our framework takes exactly 10 minutes. The clinical trade-off is that a generalized model will have a marginally higher false alarm rate than a personalized one. However, in an ICU, having an immediate working adversary system with an acceptable false alarm rate is significantly more valuable than waiting weeks for a perfect system. Our protocol successfully prevents the severe hallucinations that normally break generalized models. In conclusion, we have demonstrated a framework that completely bypasses the co-start problem, providing immediate Moving forward, our research will focus on a future paradigm. We envision a system that starts frozen for immediate safety, but dynamically unfreezes over weeks, gently adjusting its statistics to become perfectly tailored to the patient over time. Thank you.
Thank you so much for your presentation. As session chairs, I would like to ask, do we have any questions, please?
Yeah, thank you. Thank you for your presentation, ma'am. So how could this framework be integrated with collaborative tools to enhance team-based task management?
I'm sorry, could you please
Yeah,
repeat the
sure.
question?
How could this system or framework be integrated with collaborative tools to enhance, to promote the team-based task management?
Can I get what you meant by the team-based task management, please?
Yes, in your system, in the medical treatment, for example, how could you be integrated collaborative tools?
If you mean like a unified research and task management tool, if I'm
Yes, sure.
so then in that case, we can use like Notion plus AI since like we manage multiple research threads, then Notion can act as a single source of truth. So you can like link technical documentations directly to the database.
Okay.
I hope I answered your question.
Yeah, sure. Thank you. Thank you, ma'am.
Thank you.
Yeah, I don't have any question.
Yes, sir.
Thank you so much for your presentation, ma'am.
Thank you.
Thank you. Now moving on, I have our next presenter, Sir Pius Khan H, presenting a paper on the title, AI-driven multi-disease prediction system using random forest algorithm. I request you to kindly take over with your presentation, please.
News picture giving case in all the participants. Good morning. Thank you for the opportunity. Then I'll stand for you.
Yes, sir, your screen is visible.
I am Fayaz Khan, undergraduate student looking my Bachelor of Engineering in Computer Science Engineering with Riksha College of Engineering and Technology, Tamil Nadu, India. And today my presentation is all about the AI-driven multi-disease prediction system using a random forest algorithm. So moving on with the details, we'll have browse, and then the problem state. So like in the increasing complexity of the healthcare demand, we do require systems for the early assistance of the detections and the predictions of all the diseases and fatalities. So, and in this case, we need some comprehensive and sophisticated systems in this era to assist us with early diagnostics and help us to eradicate the severeness of all the diseases. But the existing system takes literally takes have more time, like it's being so time constrained and also being so complex with the built-in functionality that uh, lets us to track the process as uh, even before eradication. So like that's the problem we need to address. The early diagnostics and prediction is not assisted as to as per we have recently found. So the objective of our project of this research to address this issue is to to develop a software that helps us in identifying the multiple disease prediction systems, which helps us to which helps us identify all these with the input we have given. We can able to produce the output. We can the help is for the diagnostics and the healthcare field. The key goals of this is to design a system that accepts the patient details as the input, and then all these medical health data will be analyzed and before processing, it will be cleansed. We do have some mismatching values and it may have some different patterns over time. So before all these processes, data is cleansed and it's storing with it. Okay. The predictive results are provided to the user after carrying out all the tests we are required to with the help of machine learning modules. And these models assist us with a better accuracy rate that is compared with even getting better before the previous existing models. The existing system is a single disease prediction system. I don't say that we don't have any multi-disease prediction system right now. It do exist, but only the top medical institutes and the research institute will be using it only for only for their own purposes, only for carrying out their own work. So these are all the disease prediction system, diabetes prediction system, and then the chronic pulmonary disease, lung disease, and Alzheimer's. These are all the common disease systems we do have for a single separate disease. Our proposed system uses machine learning models and deep learning modules that is integrated with AI to create a software of multi-disease prediction system that is user-friendly, where user can access it by it is trained using the natural language processing, so that user can interact with it and then get their suggestions with the inputs provided and with the data we are sending it as out. This is the basic workflow of Magify. Magify is the research software we are developing. And first, the initial process is the patient visits the software and enters the input data. We do have a chat board where we can interact with it. Like we'll just see what are all the symptoms we do feel, or if even if we do have any medical reports, we'll be submitting all those medical reports. That's the data input, and then the input is verified, and then all these uh, data are validated. It moves on to uh, compare itself with the disease patterns and trends with the pre-trained models that we have integrated with our software. And then the exact condition is predicted, and the suggestion is not a remedy measure. A suggestion is provided to the user for the early assistance. The core point in building this software is not to replace the clinician or any technician. It is just an assisting device for the early identification of diseases. These are all the modules I have used in this software. Uh, so, starting off with the user input, user which is the software. So we can interact it. So that is definitely a user interface. For that user interface, we have used the web application module that definitely connects the user, the patient, and the software. And the fast API we have used it for the backend, and then the data processing module and the programming language we have used to build the software is Python. So we have option to choose standard and NumPy for these open source libraries we can use. And the machine learning module we have used here is scikit-learn to train the model, and the model management module. The module we have used here is Hugging Face. So why these modules when all other alternatives like for the web application modules you have Flask and Django used everywhere, and then for the understand NumPy, we do have LightGBM, and instead of Scikit-learn and having transformers, we do have TensorFlow for the management, and why this is will I'll explain why these modules we have used here, along with the technical specifics. Yeah, the program, as I have mentioned earlier, the programming language we have used here is Python, and the web framework for the backend is Fast API. The database we have loaded with the train modules is ICTIS files, and the data processing is handled by the pandas and NumPy. Model training is done with scikit-learn. Machine learning models we have used random forest algorithm as a primary learning algorithm, and for a baseline comparison, we have used logistic regression. And for the model management, we have used Hugging Face. Why these why these tech stack instead of other alternative? Uh, in this existing system, for the single disease prediction system and the complex multi-disease prediction system. Both use deep learning and a convolutional neural network, which requires many complex structures and complex technical stacks. So these are all the basic and widely
Sorry
used.
to interrupt you, sir. However, we have crossed our 9-minute mark. I just request you to kindly wind up as soon as possible, please.
I'll be finishing in a. So this is the technical specification we have used. Then what are all the applications? The objective is to The objective of this application is for the early diagnostics, and it should be widely used for the society. It should be used for the people. If this software works well, we can use it in clinics and hospitals for the early identification of diseases. We can use it for the research works in the institutes and primary healthcare centers for all these policies. These are all the applications we can use. And the results and discussions so far, we have completed to 60 to 70% of our research project, and everything suits well. These training scores were evaluated with the previous results, and we have matched an accuracy of 80 to 85%. We are still expecting 92%. This is just the main. I don't have the implementation right now. This is the code set we have used for the latest MVP viable product we developed. And the future work is about to develop this software in complex structure using the deep learning techniques for more than 30 plus diseases. Now we have tried for 12 diseases, and only 10 diseases are in the existing systems that are used by the Chalk Research Institute. And then the research and discussions. This approach helps in early diagnostics, reduces diagnostic time and supports the intervention. The system highlights the importance of combining the data-driven and AI in the healthcare system. These are all the reference papers. I have took all these papers contribute only to the single disease prediction system. And thank you everyone for your time. And if you have any questions,
Thank you so much for your presentation, sir. I would like to ask our session chairs if we have any questions for you.
Yes, sure.
Professor
Thank
Hector.
you. Thank you for your presentation. So, what methods or technology could be developed to process large-scale medical data for multi-disease prediction?
For large scale healthcare data, even these algorithms and these techniques could work, but to match the accuracy level at when compared to a complex structure, we could prefer with the convolutional neural network.
Okay, and what kind of computational resources we need to support this kind of systems?
For these systems, we do require for the first important thing is that they require the trained PKL models that are the base of this training system. If all those trained models support well, we could match with whatever the machine learning models, we could adopt it to the integration.
Okay, thank you. Thank you, sir.
Pius, have you used any classification method?
Sorry, sir, could you repeat it again?
You haven't used it. You have used any classification methods?
Sir, no, sir, I haven't made any class. I haven't used any classification method. Since I've with the beginner level and basic tech stack to develop a viable product, I haven't moved on to any complex classification.
Okay, thank you.
Thank you so much for your presentation, sir. Now I would like to call upon our next presenter for this session. Sarah Rahim presenting a paper on Aspects a lightweight multi-view forensic framework for low payload compressed audio stagnalysis with dual level explainability. I request you to kindly take over with your presentation, please.
Thank you. I'll share my screen now.
Yes,
I hope I'm audible.
yes, ma'am, you're audible.
Can I know if my screen is visible?
Yes, it is visible.
Great. So, good morning, everyone. I am Sarah Rahim, an undergraduate at the University of Westminster, affiliated with IIT in Sri Lanka. So, today I will be presenting AUSPEX, which is a lightweight and explainable framework, mainly for detecting low payload audio steganography in compressed speech, especially in the G729A domain. So the key focus is not just detection in my area, but forensic usability. This means understanding why a model flags something as steganographic or harmful, not just the detection result. So coming to the problem and the research question, compressed audio steganalysis is difficult for three main reasons. So first we have low redundancy. G729A bit streams have a very limited structure. So traditional image style or waveform-based detectors don't really work well here. Second, we have low payloads at 0.1 to 0.2 bits per coefficient. The modifications are extremely subtle and are very much buried under normal codec variations. Third, we have low trust. So in forensic or SOC settings, a prediction alone isn't enough. You need evidence attribution. So the research question becomes, can we design a model that operates directly in the compressed domain, detects low payload steganography, and still, in the end, provides meaningful explanations. The target here is not just accuracy, but a usable forensic detector. In here, the core idea is to stop treating the bitstream as a flat binary data and instead convert it to multiple forensic views. In here, we have a 5-channel representation. We have raw bits to preserve the structure and temporal difference to capture the bit flips, bit stability to highlight abnormal patterns, and 2 fixed high-pass residuals to amplify the subtle disturbances in the audio. This is very important because in the end, low payload steganography doesn't just alter raw bits strongly, but it also introduces small temporal inconsistencies throughout the audio. So by explicitly defining these features, we are increasing the signal before the learning even begins. Instead of hoping the network discovers these patterns, we force these features onto the model. So when we talk about the architecture of Auspex, the model itself is designed to stay lightweight. It uses the depth-wise separable convolutions, attention mechanism, and statistic pooling with a total of about 170,000 parameters. Training is done on around 20,000 samples, as seen here, using CNV and PMS embedding methods across payloads from 0.1 to 0.4. We also use weighted loss to handle the imbalance at low payloads. The key point here is that it's not just a large compute-heavy model. It is designed to be deployable in real-time or edge forensic settings. When we talk about the dual-level explainability in my model, first we have spatial attention, which highlights where in the bitstream the model is focusing. Second, integrated gradients provide channel-level attribution. So in the end, they show which representations contributed most to the decision. One interesting finding is that the bit stability channel becomes dominant at low payloads. So this aligns with the intuition that subtle irregularities or perturbations are more informative than raw values. So explainability here is not just visual. It actually supports the forensic reasoning behind our model. Moving on to the results, in terms of performance, the model achieves 61.7 accuracy, 6.7 AUC overall, and a peak CNV AUC of 0.89. However, performance is significantly lower for PMS with the AUC around 0.57. So the takeaway here is very clear, as I stated at the first. The model works reasonably well, especially for easier embedding methods, but low payload detection accuracy remains inherently difficult. This is not a solved problem, and the results reflect that honestly, this has been stated in existing work, and it is not a gap that I'm solving. When we come to the benchmark position, when compared to existing methods, Auspex does not achieve the highest raw accuracy. However, it achieves comparable performance with significantly fewer parameters. More importantly, it provides explainability, which many competing models lack. So the contribution is not beating every benchmark. It is showing that you can combine efficiency, compressed domain operation, and interpretable outputs into one single framework. So when it comes to the ablation study, removing the high-pass residual stated earlier causes the largest performance drop. So it confirms that when you amplify the subtle perturbations, it contributes a lot towards the model. Tensor-based representation also helps, particularly for harder cases, for example, 0.1 payloads. Interestingly, attention has minimal impact on raw performance, which suggests its main value is in interpretability rather than accuracy. So this reinforces the design choice of treating explainability as a first-class component. When it comes to the conclusion and future work, Auspex demonstrates that lightweight, compressed domain stag analysis is feasible even at low payloads. The key contributions here are a structured multi-channel representation, integration of forensic-inspired residuals, dual-level explainability. However, limitations remain, especially for harder embedding methods like PMS and very low payloads. Future work will focus on extending to other codecs, improving robustness, and strengthening the validation of the explainability methods. So that is all from my presentation. Thank you very much.
Thank you for your presentation, ma'am. I would like to ask our session chairs if we have any questions for her.
Yeah, thank you. Yeah, thank you for your presentations. So, what techniques can be implemented to improve the model's ability to reveal bit level and channel level evidence?
So your question is what techniques we can implement into the current model to improve its representational value. I'm correct?
Yes.
In detection?
Yes.
Okay. So currently, I think the high pass layer is very influential in my model. It amplifies the representation and that contributes a lot towards the accuracy. So I suggest if we work on improving the high pass layer, maybe adding more or improving the current layer would make it even better. And also if we could add more feature representations to the current 5-channel input, it would increase the value.
Okay, thank you.
Thank you.
Hello, ma'am. Your presentation is good. I have a question. How you want to use the extended AI validation?
Sorry?
How you want to implement the extended AI validation in your
So your question is, how do you want to do the XAI validation?
Yeah. Yeah.
Okay. So there would be one way, it would be like I stated, using faithfulness tests. So I could compare my current method, which is integrated gradients, with other methods such as occlusion, Lime, SHAP, and see which method is better when analyzing the different channels. So in that, I can validate that my explainability method is also having good performance. That would be one way to validate it.
Okay. Thank you.
Okay, thank you.
Thank you so much for your presentation. Now I'd
Thank
like to
you.
call upon our next presenter for this session. Our next presenter is Mohammad Mehdi Rahman Rana, presenting a paper on the title Development of a Comprehensive Fake Image Detection Dataset for Social Media with DCT-based Evolution. Sir, I request you to kindly take over with your presentation, please.
Thank you very much. Is my screen is visible to everyone?
Yes, now it is visible to us.
Good morning, everyone. I am Mohammad Mehdi Rahman Rana, Associate Professor and Head of Department of CSE at Army University of Science and Technology, Bangladesh. My paper ID is 1140. I am pleased to present our work titled Development of a Comprehensive Fake Image Detection Dataset from Social Media with DCT-based Evaluation. This research is a collaborative effort between Khulna University and Joshua University of Science and Technology, Bangladesh. The motivation behind this work comes from the rapid spread of manipulated images on social media, which can significantly influence public perception and contribution to misinformation. In this work, we propose a new dataset called FID 4000, a DCT-based baseline detection method, and a comprehensive evaluation under realistic social media condition. This is the outline of my today's presentation. Now I describe the problem statement of my research. Fake images are becoming increasingly common in today's digital ecosystem. A key challenge is that these images are not shared in their original form. Instead, they undergo multiple transformations such as compression, resizing, platform, specific processing, and the addition of noise and overlays. This transformation often hide and distort important forensic traces, making detection significantly more difficult. Another limitation is with existing dataset. Many of them do not reflect realistic social media contribution and lack detailed annotations for deeper analysis. As a result, there is a strong need for a dataset that capture real-world complexity, including compression artifacts, platform-specific distortion, and comprehensive labeling. This is exactly the gap of our work to be addressed. To address this challenge, we introduced FID 4000, a realistic benchmark dataset. It contains 4000 images, where 1000 authentic and 3000 fake, collected from different platforms like Facebook, Twitter, X platform, and WhatsApp group. We provide pixel-level mask for localization and include multiple manipulation types such as splicing, copy move, and retouching. The dataset also includes rich metadata like source platform and manipulation context. Importantly, since 75% of the images are tempered, the dataset emphasizes the need for high recall and robust detection methods. This slide outlines our overall methodology, which includes both dataset construction and baseline evaluation. First, we collect authentic and manipulated images from real social media platforms like Facebook, Instagram, and WhatsApp, while preserving platform-specific efforts such as compression and noise to ensure realism. Next, we create pixel-level ground truth masks, enabling both detection and precise localization to manipulated regions. We also generate structured metadata, including manipulation type, source platform, and context, allowing deeper analysis across different scenarios. After building the dataset, we apply DCT-based methods as a baseline. These work in the frequency domain to detect inconsistencies caused by the manipulation. Finally, we evaluate performance in two ways: detection, first detection using matrix life accuracy and F1 score. After that, localization using intersection over union, that is IOU. Overall, this pipeline ensures a realistic dataset and comprehensive evaluation, highlighting the challenge of fake image detection in real-world condition. Now let's look at the DCT-based detection pipeline. DCT, or discrete cosine transformation, converts image data into frequency domain, where manipulated artifacts become more visible. The process consists of four main steps. First, pre-processing. We convert the image to YCV-RC used to eliminate channels and resize if needed. Second, block-wise DCT. The image is divided into 8x8 blocks, and we extract low frequency AC coefficient. Third, detection for copy move. We identify repeated blocks, and for splicing, we detect recompression inconsistencies. Finally, decision. If the detected signal exceeds predefined threshold, the image is classified as fact and roughly localize its position. We choose DCT because it is interpretable, sensitive to compression artifacts, and effect as a strong classical baseline. Here are the results of the DCT baseline on FID 4000. We achieve 82.48% accuracy and 96.5% precision, 83% recall, and F1 score is 89.3%. This result shows that the model is highly precise, meaning very few false positive. However, the recall indicates there is still room for improving the detecting all fake images. The specifically for authentic images around 85%, suggesting some misclassification due to complex compression patterns. Overall, these results confirm that the dataset is challenging and real-world social media artifacts significantly impact detection performance. Let's interpret these results more deeply. First, performance drops compared to the simpler dataset, configuring the real-world conditions significantly increasing directly. In terms of manipulation types, copy mode performs best due to strong repeated patterns. Splicing performs moderately well, and retouching is the most challenging as editors are subtle and leave weak trace. Common failure cases include small edits, low consistent change, and images are complex compression histories. This indicates that relying on a single domain such as frequency is not sufficient. To conclude, our main contribution is the FID 4000 dataset, which provides realistic social media images, pixel level mask, and rich metadata. We also presented DCT-based baseline achieving 82.48% accuracy, highlighting both its strength and limitation. The key takeaway is the fake image detection becomes significantly more challenging under real-world social media condition. For future work, we recommended leveraging deep learning models, combining multiple feature domains, and improving localization accuracy. This research work is funded by ICT Division of Government of the People's Republic of Bangladesh through an ICT fellowship. Thank you for your attention.
Thank you so much, sir. I would like to ask our session chairs if we have any questions.
Yes, thank you. Thank you for your presentation, sir. So how can new data sets be designed to better capture real-world compression effects and improve detection and localization methods?
Thank you, sir. All of my images are collected from social media. No images is further pre-processed or it is directly collected from social media. And when you share any data from social media, it quality is changed. Suppose it compresses the picture size and also the quality. So this is the main feature of my dataset. All the dataset is real and authentic, and there is no further pre-processing.
Okay, thank you.
Thank you, sir.
No, I don't have any questions.
Okay. Thank you so much for your presentation, sir.
Thank you so much. Thank you.
Now I would like to call upon our next presenter for this session. Our next presenter is Cristiano Santiago, whose is presenting a paper on the title Digital Twins and Multi-Chain for Preventive Academic Degree Fraud, a Case Study.
Thank you so much, ma'am.
Thank you so much, sir. I request you to kindly take over.
Sorry, it is possible maybe to one of our teammates make the presentation?
Yes, please.
Perfect. So, well, good morning, everyone. It is a pleasure to be here at ICTIS. Before we begin, we would like to introduce ourselves. My name is Cristian Santiago Jimenez, and I'm joined by my colleagues, Joan Sebastián Ayala and Leonardo Juan Ramírez López. We are a research team from Universidad del Bosque in Bogota, Colombia, a country known as the land of coffee, rich in natural beauty and cultural diversity. We warmly invite you to visit our country someday. So our work focuses on the intersection of emerging technologies and social integrity. And today we're excited to share our last development, that is a hybrid model to prevent university degree fraud based on blockchain and digital twins. To understand our research, we must look to a global crisis, the academic forgery, and every year approximately 200,000 fake diplomas are sold worldwide. In our home country, Colombia, this issue has reached to the highest levels of government, with cases of public officials, including members of Congress, holding positions based on unverified credentials. Even the HEDD in the United Kingdom emphasized that centralized verification is not longer enough. We believe that by using digital twins and multi-chain, we can mitigate this problem. So, next, please. Currently, academic certification is a manual bureaucratic process prone to a human error and internal tampering. Our research identifies a major scientific challenge. Traditional systems rely on centralized databases that represent a single point of failure. If the database is compromised, the institution's reputation will be destroyed. So we propose a move toward a decentralized architecture where the student's record is an immutable digital shadow. Okay. Well, next please. Here, we can see that our model follows a three-chart decouplet monolithic architecture. After a rigorous comparison of DLTs, we selected multi-chain over Hyperledger or Corda due to its superior balance of performance, security, and low cost for academic environments. For the logic layer, we utilize Python, the version 3.14.3, and Flask, which ranked architectural decision was to entirely bypass relational databases like Postgres, but at the final, we ensure to use only blockchain remains the absolute source of truth. So next. Next, please. Go on. Perfect. Here we represent the student's life cycle through a digital twin. So this twin evolves as the student completes academic and administrative requirements, such as Saber Pro. This is an exams, this is an exam that we do right here in our country, and financial clearances. Each step is verified by different university roles, like secretariat, the director, councils, and the rector at the final, ensuring that the diploma is a result of the cryptographically signed sequence of events. Next, please. In the next slide, we can see a video of our prototype twin chain. Redefines diploma insurance through cryptographic ecosystems where every institutional role becomes a key actor. The process begins in the IT administration panel, as you can see. This is where the system's foundation is established. The student spaces records, and as you see, is created, and the academic file is officially opened. Once we created this, the process moves to the academic registry office. They evaluate all required conditions, certifying elements such as tuition payments and library clearance. But what happens if the information, as you see, is incomplete or an anomaly is detected? Our system introduces an incorrectable correction cycle. If the academic office misses a requirement, the system cryptographically seals the diploma and not the level, and escalates it to the program director. As you see, the director then reviews the digital twin and all the red flags and activates the return flow. This is the example of a correct process. And then we use all these resolve data and reevaluate the diploma transition to an eligible status. From this point on, the main record is created on the blockchain. The system encrypts all the student data using SHA-256 security, generality, and immutable DNA of the diploma. The directive change, the director, the council, and director then takes over. They are no longer rely on the paperwork, or some excessive manual reviews. Instead of that, they access the system and digitally sign the record. With each click, the local multi-chain network generates lightweight transactions that are true to the original academic record. Finally, when we audit all these processes through our Twin Chain Explorer, we can observe everything in real time, as you see in the Twin Chain Explorer. Instead of exposing incomprehensible hexadecimal strings, our custom-built Explorer connects the backend directly to the blockchain engine, and it transparently translates each block, clearly showing which institution and which authority signed the diploma. This ensures full traceability for the university, eliminates any possibility of fraud, and guarantees absolute data integrity. Next, please. To ensure transparency with the lab, the Twin Chain Explorer, this dashboard allows for a real-time monitoring of node status and block height. Most importantly, it provides a public audit trail where each specific diploma is linked to its unique TX IDs. Next, please. In the final output, as we see in the video, our system is this official digital certificate. This is marked as officially issued and includes a unique identifier. Most significantly, it displays the cryptographic hash of the digital twin, because the system has zero sensitive database reliances. The document is mathematically impossible to forge. It has been ensured for the multi-chain ledger. Next, please. Thank you so much. In conclusion, we have that our hybrid model successfully addressed the vulnerabilities of traditional academic certification by integrating digital twins with blockchain. We provide a scalable, security, and transparent solution for institutions worldwide. See you in Colombia, all of you. Thank you so much.
Thank you so much for your presentation, sir. I would like to ask our session chairs, do we have any questions?
Yes, sure. Thank you. Thank you for your presentation, sir. So, with all this architecture, what type of computational resources will need to implement this kind of architecture?
Correct. So basically, are you asking what other resources can be implemented in the prototype to improve the functional of the prototype, or
Yeah, yes, to use this system, this architecture.
Correct. Well, the most important thing right here is that we are using this prototype in a native device that simulate all the process. And one of the most important sources is create each node in each server of university. For example, the node A can be located in the rector's office. The node B can be located in the university, and the other one can be located outside. Other one is really database that can allow that can afford all these data and let us select all this information of the students more efficiently.
Okay. Okay. Thank you.
Thank you.
No, I don't have any questions.
Thank you, sir.
Thank you so much for your presentation, sir.
Thank
Now I
you.
would like to call upon our next presenter for this session. Our next presenter is Asmit U. Patel,
Yes, ma'am.
presenting a paper on the title GreenSec DPO, a trust-aware, carbon-aware, and post-quantum secure multiple objective task scheduling framework using dung beetle optimization for sustainable cloud computing. I request you to kindly take over with your presentation.
Good morning, everyone. I am Asmit Badel, and today I am presenting a paper titled GreenSec DBO, or Trust Aware, Carbon Aware, and Post Quantum Secure Multi Objective Cloud Scheduling Framework. This work focuses on solving a modern cloud computing problem, how to schedule tasks efficiently while also considering security, sustainability, and future cryptographic requirements. Then, traditional schedulers mainly focus on performance, but in today cloud environment that is no longer enough. So in this work, we propose a framework that jointly optimizes make span energy consumptions and carbon emissions. Then we have abstract. The main motivation behind this work is that cloud computing environments are becoming more complex due to increasing workloads, high energy consumptions, rising carbon emissions, and stronger security requirements. In particular, the adoption of post-quantum cryptography, or PQC, introduces additional computational overhead. That means scheduling decisions can no longer be based only on speed. So in this paper, we propose GreenSec DBO, which is a multi-objective task scheduling framework. It aims to reduce total completion time, reduce energy consumption, reduce carbon emissions, and improve secure task execution using trust-aware scheduling. We implemented this approach using Cloud Simplus and experimentally compared it with existing methods such as round robin, PSO, and NSGA2. Then we have motivation for this title project. The motivation for this work comes from the fact that cloud workloads are growing rapidly due to applications such as AI, IoT, big data, and real-time services. As workloads increase, task scheduling becomes more difficult. So existing schedulers have several limitations. That is, they often ignore sustainability. They do not consider carbon emissions. They are not trust aware, and they are not designed for the computational overhead introduced by post-quantum cryptography. Then we have need for unified framework for performance, security, and sustainability. Then introduction for this slide. Cloud computing provides on-demand access to computing resources and is widely used in AI, IoT analytics, and enterprise systems. One of the most important challenges in cloud computing is task scheduling, which decides how incoming user tasks are allotted to available virtual machines. Traditional scheduling algorithms mainly focus on fairness, load balancing, or performance. In this, the key challenges include reducing make span, minimizing energy usage, lowering carbon emissions, handling post-quantum cryptography overhead, and ensuring that tasks are assigned only to trusted resources. Then we have literature survey. In literature survey, we observed that researchers have already worked on different parts of the scheduling problem, but not all together. For example, some works focused on efficient resource provisioning and scalability. Some proposed energy-aware scheduling using methods such as DVFS and VM consolidation. Others worked on carbon-aware scheduling, considering carbon intensity. Uh, Algorithms such as NSGA2 have been used for multi-objective optimization. PSO is known for fast convergence, and Dung-Whittle optimization or DBO has been shown promising performance in balancing exploration and exploitation. We have research gap, that is existing approaches optimize performance, energy, or security individually but do not integrate carbon awareness, trust-based security, and PQC overhead into a unified scheduling framework. Then we have existing system. The traditional cloud scheduling workflow is relatively simple. User tasks are placed in task queue. The scheduler assigns them to virtual machines and then execution takes place. Then common scheduling methods include round robin, FCFS, PSO, and NSGA2. But these systems have important limitations that are focused on only on performance, no carbon aware scheduling, no trust based security mechanism, no consideration of PQC overhead, and single objective optimization approach. The result of this is inefficient, insecure, and non sustainable task scheduling in modern cloud environments. Then we have objective. The main objective of this work is to design a multi-objective cloud task scheduling framework that is efficient, secure, and sustainable. Uh, Specifically, our objectives are to minimize make span so that tasks finish faster, to reduce energy consumption, improving efficiency, to lower carbon emissions, supporting green cloud computing, to ensure secure task allocation using trust evaluation, to incorporate PQC overhead so the system remains relevant in future secure cloud environments. Then we have methodology. The methodology of our work is based on the proposed GreenSec DBO algorithm. We use Dung-Whittle optimization or DBO as the optimization engine because it provides a strong balance between exploration of possible solutions and exploitation of the best solutions found so far. The scheduling process works as follows. First, we initialize multiple candidate task scheduling solutions. Then each candidate solution is evaluated using a fitness function. This fitness function considers multiple parameters, that is make span, energy consumption, carbon emissions, and security satisfaction. After that, DBO operators are applied to improve the scheduling solutions iteratively. During this optimization process, we also enforce trust constraints. So tasks are assigned to reliable virtual machines, and carbon constraints. So scheduling is more environmentally aware. So instead of choosing the fastest VM blindly, our framework chooses the most balanced VM assignment. Then we have proposed system. This slide shows the architecture of the proposed GreenSec DBO framework. The workflow begins with user tasks, which are first received by the task management module. Then before scheduling is performed, the system evaluates two important things: the trust level of the virtual machines and the carbon related impact of the resource allocation. The scheduler uses multi-objective optimization to determine the best task to VM mapping. Finally, tasks are allocated to the optimal virtual machines and execution is performed. The key expected outcomes of these systems are reduced mix span, lower energy consumption, lower carbon emissions, and improved security satisfaction. So the architecture ensures that scheduling decisions are not based only on performance, but also on sustainability and security. Then we have advantages, limitations, and references. The proposed system offers several advantages. First, it performs multi-objective optimizations, meaning it does not focus on only one metric. Second, it supports energy efficient scheduling, carbon aware allocation, trust-based secure execution, and future relevance to PQC aware scheduling. So, since GreenSec DBO is based on a meta-heuristic optimization approach, it introduces some computational overhead. Also, in the current work, the framework has been evaluated in a simulation environment using Cloud Sim Plus, not yet on a real cloud deployment. Then we have future enhancement. We have implementation on real cloud platforms like Kubernetes and OpenStack. Then integration of real-time carbon intensity monitoring. Then deployment of dynamic trust evaluation mechanisms. Then support for hardware acceleration of PQC operations. Then extension to edge and fog computing environments. Then we have conclusion. To conclude, this paper proposes GreenSec DBO, a multi-objective cloud scheduling framework designed for modern cloud environments. Unlike traditional scheduling approaches, our framework integrates performance optimization, energy efficiency, carbon awareness, trust-based security, and post-quantum cryptographic considerations. Through simulation-based evaluation, the proposed method demonstrates better results than conventional approaches such as round robin, PSO, and NSGA2. Specifically, it improves energy consumptions, carbon emissions, and security satisfactions. Then, therefore, GreenSec DBO provides a more efficient, secure, and sustainable solution for next-gen cloud computing environments. Thank you.
Thank you so much for your presentation, sir. I would like to ask our session chairs if we have any questions for you.
Yes. Thank you. So how can the proposed dung beetle optimization be tested in real-world cloud systems to evaluate its effectiveness?
Sir, actually, dung beetle optimization we have used in this paper like already it has been researched on that algorithm. So we have taken the research of the other papers and then we have made the analysis of the algorithm to be more precise and accurate.
Okay, and what type of parameters we use to measure this effectiveness?
We use other algorithms like round robin, NSGA2, and yes, many more like that.
Okay, thank you. Thank you, sir.
Your presentation was very good. I have a question for you. You
Yes,
have
sir.
used round robin as well as PSO, right? So there are other algorithms for the quantum cryptographic processes like the Torres algorithm. So did you go for any comparative study for that, and what is the accuracy for that?
Sir, actually, in the paper, we have mentioned the analysis of the full dung beetle optimization algorithm with the percentages till what extent it is accurate and precise.
And what is your data set? Why you have taken the data set from?
No, sir, we are not using the data set here.
Okay, got it.
We are just using the algorithms. Means we have taken some older research that has been done on the dung beetle optimization, and then we have analyzed and made the algorithm more precise.
Okay, fine. Thank you.
Thank you so much for your presentation, sir. I would like to call upon our next presenter for this session. Our next presenter for this session is Felipe N. Coelho, presenting a paper on the title Hybrid System of Deep Learning and Neuromorphic Computing for Energy Prediction in 5G NSA Networks. I request you to kindly take over with your presentation, please. So, Felipe. If anybody else is on his behalf going to present, I request you to kindly take over. Okay. So as we don't have anybody on his behalf or the presenter right now here, we'll be taking our next presenter for the session. Our next presenter is Sir Udayamurthy Venkatesh Kumar, presenting a paper on the title Improved Rotor Position Estimation and Estimated Error Conversions using Sliding Window in Extended Kalman Filtering in BLDC Motor for Dual Axis Solar Panel Tracking System. Sir, I request you to kindly take over with your presentation. Yes, sir, we can see your screen.
So, good morning to everyone. Solar panel panels. So, this is our agenda of today's presentation. Abstract problem statement, research gap methodology, key findings. So, in our abstract, in dual tracking system, two angles we are going to concentrate. One is your azimuthal angle, in two parameters. Your RK and QT. These are the two things which is present in the Kalman filter. That only we are going to modify. That is noise for process noise coherence value QT and the measured noise coherence value RT. And our result source azimuthal angle 66%. Let us see how to. So
I'm sorry to interrupt, sir. However, there is a slight disturbance in your voice.
Oh.
Okay.
Is it now okay?
Yes, sir, it is better.
Yeah. And dual axis system, our rotor position, variation in wind speed are impacting more. So we are going to consider these parameters and improper maintenance of mechanical system also plays a major role in tracking system. So in literature survey, only few papers we are going to show it here, which is contributed in 2025 year. So the methodology what they used in paper one is two linear potentiometers served as sensing elements. They showed efficiency around 27% increase. And in the second paper, they used the methodology comparative study of with respect to static and with respect to tracking. So when you compare with the static as well as with the tracking shows a better performance. And in the third paper, methodology what they use is precision sensors and adaptive control algorithms, and efficiency is about 30% we have improved. And in the fourth paper, they are using servo motors and the 4 LDRs they are using, and 45% improve in the efficiency. So this is our system model. So we are using STM32 microcontroller, our BLDC motor, and we are incorporating sliding window assisted estimated Kalman filtering algorithm in the microcontroller, and it is connected with the BLDC, and the BLDC is connected with your solar panel. So what are the parameters we are considering here? are two motors we are going to use for each angle, azimuthal and elevation, separate motors, and rotor position and angular speed are interrelated. So theta and omega, okay, they are interrelated. And the other parameters we are incorporating is moment of inertia, motor torque, wind disturbance, and gravity torque. So gravity torque alone, it will be along the elevation, but remaining parameters which will contribute both along vertical as well as horizontal, that is azimuthal as well as elevation. And in our system, we are going to frame the space-time model equation. For that, all the physical system dynamics, we are considering it as a input x of t, and two motor controlling azimuthal and elevation are taken as input control inputs, and the wind speed, which is considered as a noise here. Because of that wind speed only, our rotor position is disturbing, and control it is not able to predict the or it is not able to fix the or track the solar sun radiations. Okay, that is taken as a noise here, that is d of t. So we are framing the continuous state space form, which is it is linear time invariant as a x of t here, which is given as a of x of t, b u of t plus d of t. So matrix A and matrix B, which is with respect to A has so many zeros that indicates there is no coupling, and A12 and A34, that is equated to 1 because it is with respect to the velocity along the azimuthal angle, and with respect to elevation angle, B with respect to moment of inertia. So this microcontroller is going to convert the continuous time process into a discrete with respect to sampling, and this is the equation we are framing. Function f of which takes x of k and u of k, and w of k is the noise, process noise with respect to rotor speed and with respect to position. And when compared to the rotor speed, position is not much affecting. Rotor speed alone, that is omega, which is equal to 2 pi f, that rotor speed is dominating the performance here. So if you take, this is the equation. In the microcontroller, we have incremental encoder, which will identify the angular position. So that is given by y of k equal to h of xk plus vk. Vk is again the encoder noise. So xk is the estimated rotor position and the speed. Okay. So here h indicates the your azimuthal angle and the elevation angle position measurement matrix h. Okay. So this is our already existing. So these are the parameters we have taken. Already existing estimated Kalman filtering will have the predicted covariance equation and the Kalman gain, which is given at last in this slide. That is P of Pk and K subscript K. So this only we are going to change it, and you can see RK, which is the measurement noise covariance, that only we are going to modify it. So how we are going to change it? We are going to include the incorporate the sliding window concept for 50 samples. So n equal to 50. For sliding samples are taken as a W of k. So k minus n plus 1 to we are taking up to k, and now the previous you can see this previous equation in this yk equal to h of xk plus vk, that is here modified because v of k is a noise. Noise is nothing but your rotor speed. So that only we are going to predict it. So the new predicted encoder noise is calculated using the last equation vk equal to yk minus h into x cap of t. So now vk is you can see we have included the new noise factor vk with respect to the sliding window samples. That is v of along azimuthal angle and v subscript el, that is along the elevation angle, with respect to your sliding window samples. So the noise covariance matrix, that also here we estimated value, there is a out of n samples, we have calculated the covariance here. So that is a R matrix with respect to azimuthal as well as the elevation. And we are introducing two parameters. One is the smoothing factor. This is the first factor because wind speed we cannot determine. It is randomly keep on changing. So a smoothing transition parameter lambda we have introduced. So this smoothing factor will range from 0.9 to 0.99. And now the modified equation, that is your covariance matrix RK, is nothing but including this lambda smoothing factor we have modified and we have written here. And your RK is now having the expected value as a VK transpose. And another parameter we are introducing is the tuning factor, which is the process noise. So this process noise, we have introducing the tuning factor. This tuning factor, when it is equal to 1, the system is very reliable. That is, wind is not much affecting. When it is less than 1, wind is affecting our tracking system. That indicates it is affecting our tracking system. We need convergence very quickly. But when your tuning factor is greater than 1, your wind speed is very high and it is very uncertain, and the convergence should happen at a very high speed. Okay.
I'm really sorry to interrupt you, sir. However,
Yeah.
we have crossed our 9-minute mark. I request you to
Okay.
kindly conclude as soon as possible.
Okay, so these are the simulation results. So it's an azimuthal angle at a 0.363 seconds. Our sliding window shows an improvement with 50%, and elevation angle, this we have done with the Python code. It shows 55% improvement with respect to conventional, and error convergence we can see it can rise up to 66% along azimuthal, and elevation with 70%. And this is our conclusion. Using the sliding window method, it shows better performance. So rotor positions have improved more than 50%, and the error convergence have improved more than 66% and 70% along elevation angle. So this is our work we have done. Thank you.
Thank you so much for your presentation, sir. I would like to ask our session chairs if we have any questions.
Yes, thank you. Thank you for your presentation. So how can the proposed estimation method be validated for real-time implementation in solar tracking systems?
Professor, here I have considered in Python simulation only one solar panel with weight up to 35 kg. And it is a bifacial monoperk panel we have considered. With a single panel with a microcontroller, considering the microcontroller STM32, we have simulated. But in future scope, when so many, it is a very large solar generating plant. If everything is integrated, that we have to practically we have to do it at a prototype level. We have simulated with this Python code. You considering only these things, and the motor speed, that is 0 to 400 RPM alone we have considered. When it is a large size system, definitely we have to check it.
Okay. Okay. Thank you. Thank you, sir.
Yeah. Thank you so much.
Yeah, I don't have any question again. Thank you.
Yeah. Thank you.
Thank you so much, sir, for your presentation.
Yeah. Thank you.
you.
Thank you so much.
Now I would like to call upon our next presenter and our final presenter for this session. Ananya Kale, presenting a paper on the title Singer Identification via eKappa, TDNN, and Classical Machine Learning Models. I request you to kindly take over with your presentation, please.
Yeah, sure. Yeah, is my screen visible?
Yes, ma'am, it is visible.
Thank you. Greetings to everyone present. I'm Ananya Karil. I'm in my final year of undergraduate studies at Cummins College of Engineering for Women in India. I'm studying computer engineering. I'm here to present our paper on single identification via eCAPA TDNN and classical machine learning models. Coming to the introduction and motivation. So, single identification, as its name, is aimed at automatically recognizing the identity of a singer from an audio recording. It is generally more challenging because, unlike speaker recognition, it has melodic variations, pitch changes, and there is expressive variations in singing styles of each singer. There have been studies in which feature engineering, CNNs, and RNNs were used to capture spectral and temporal features of singing voices. But we found a gap where there was limited research on the use of pre-trained speaker embeddings, particularly used for the case of singer identification. Most of the existed studies relied on handcrafted features or deep learning models. So this study is a novel approach towards singer identification, where we explore the use of eCAPA TDN and embeddings along with classical machine learning classifiers. This is some literature survey that we did. Basically, we could find all existing literature on singer identification grouped into these 4 or 5 categories. First is feature-based machine learning, where a combination of handcrafted and hybrid features were used, but it was not so good at generalization for singer identification. The next was the use of CNN and LSTM models, which was very prominent. It was a deep learning approach, so it required a large amount of computing power, so it was not very efficient. The next one that we found was CNN used along with BiLSTM. This was a hybrid deep learning approach, but again, it was very resource intensive. We found representation learning, which was again embedding based, but it did not offer much interpretability. The next part, which was very important, we could find some speaker embedding based literature done on eCAPA TDNN, but it was not tailored for singing voice or never used for singer identification. So our proposed work tries to use it in combination with classical machine learning models to prove on how accurate results can be interpreted from less data. And this approach remains underexplored, and this is what we have studied in our paper. Dataset. So this is the methodology that we used. So we performed some pre-processing on our data. So we used fixed length 8-second clips of singer voices. There were 1000 clips that we used, from which we ran eCAPA DDNN as an encoder. So we extracted vectors out of each audio clip. So we got an array which was of 1000 by 192 dimensions. So we used this extracted and aggregated embeddings, and we passed it to some classical machine learning models such as logistic regression, support vector machines, random forest, and MLP, from which we could get the best model as MLP. So we used it as the final model for our inferences. This is some outstanding accuracy that we could achieve from our research experiments with logistic regression with support vector machines giving 96%, random forest doing the lowest towards 95.63, and MLP giving us the highest one. So with this results, we could prove that we can make robust singer identification systems using frozen speaker recognition models such as eCAPA. So it is highly efficient. Unlike deep learning, it is less resource intensive. And how eCAPA is successful in capturing some unique spectral and vocal features of a singer. Coming towards the conclusion and the future scope for our research, on the right hand side, you can see a cluster TSNE projection of our project. You can see 2 separate clusters. So these were the male and female singers, where you can see a clear cluster separatability. The female singers had a kind of a similar voice, which can be easily mistaken. So we could find some crossing on the embedding on the clusters made for those singers. But for the male singers, we could find again a clear cluster separability. So this again proves how ICAPA can be used for singer identification purposes and is also highly accurate in identifying singer voices correctly. We could achieve a 99.38% accuracy using MLP, again proving how deep learned models along with classical machine learning classifiers give you an accurate and efficient way other than using deep learning, which is which uses a high amount of compute power. As the results look promising, we could get higher accuracy. Our future work includes expanding this project to more singers, involving a better variety of musical genres and exploring other approaches in which ECAPA-TDNN can be utilized, or some domain-specific alterations which can be done, or exploring some fine-tuning approaches towards this. Thank you. That's all from my side. And these are some references that we have also put in the presentation as well as our paper. So we studied 18 such references. Thank you.
Thank you so much for your presentation, ma'am. I would like to ask our session chairs if we have any questions.
Yes, thank you for your presentation. So what additional features or data sets could be incorporated to improve the performance of singer identification systems?
So additional data sets would be having access to some archival models, say musical archives which have not yet completely been explored, or a full metadata of which has not been established. So this is where we can make our model and train it better. Or we could also include some alter it to some domain specific. So there is multiple musical genres. So we could try to make it more domain specific by fine tuning it on those particular samples.
Okay, thank you. Thank you, ma'am.
Yeah, good morning, ma'am. I have a question for that. Suppose many of the singers in India, particularly, can sing in a female voice also. A male singer can also sing a song in a female voice also, right? So how can it be detected from there that whether it is a male candidate or a female candidate?
Sorry, I was not able to get your question very
Yeah,
clearly. There
yeah,
was some disturbance.
okay. I'm saying actually that suppose in India there are a number of singers who can sing in female voice also. So how can we detect those singers? That whether that is a female
So,
singer or a male singer?
okay, so what I inferred from your question is singers with similar voices, how to deal with such cases, right?
Yeah, it can be said, but my question is not like that. My question is that many singers are there, male singers are there who can sing a song in female voice also.
Okay.
Right? How can it be detected?
Currently, this was not considered as a part of our scope for this project, but we could explore approaches where if we get an access to such data set, we can demarcate it as two separate classes, wherein the normal voice is demarcated as the name of the singer with a male bracket, and the same male singer with a female bracket. So if we could make two classes out of it and use it on our training data accordingly.
And sir, basically we need to find out more features on the ground level which will be able to differentiate. Exploration of new features which can differentiate should be the next task.
Okay, okay. Thank you. Thank you.
Yes.
Thank you so much for your presentation. With this, we come to the end of our session.
Thank you, ma'am. Thank you, ma'am.
Thank you. I sincerely thank our authors for their excellent presentations and contribution in this session, and all our participants for being a part of this international conference. I hope this session was informative enough. We, on behalf of the whole team, thank you for support during this 11th version and all the previous 10 versions of this conference. We will be happy to have you in the 12th version in 2027. All the presenters will be getting their digital certificates through email within 2 working days. The publication will be live within 7 to 8 months. kindly cooperate with the team of ICTIS 2026. I would also like to thank our session chairs, Professor Hector Monoro and Professor Chatterjee. Sir, would you like to close any remarks, anything that you would like to say to our participants before we end the session?
Oh, yes, thank you. So we have reached the end of this session. So thank you all for your presence and for sharing your work with us. So we hope to have your valuable participation again next year. So have a wonderful day. Thank you.
Thank
Thank
you
you,
so
sir.
much. Sir.
Okay.
Thank you so much.
Thank you. Thank you to the coordinating
you.
team. It's a great opportunity for all the authors to go through all the different types of topics that they have given. And it's a very good project presentations for all of the candidates. Hope to see you in 2027. Thank you very much. Thank you, Prashu.
Thank you so much. I would like to show our token of appreciation for our session chairs. This is a token of appreciation from the team of ICTIS 2026 and Global Knowledge Research Foundation and partners. Thank you for your valuable presence, Professor Hector. And the second certification for Professor Deepa Chatterjee. Thank you so much, sir. Now, I just request all of you all to please switch on to your cameras so that we can have a quick snapshot of this virtual session that we just attended. Requesting all participants and presenters to kindly please switch on to your cameras so that we can have a quick snapshot of our session that we just attended. Requesting all to kindly switch on to your cameras, please. Again, I just request all of you all to kindly switch on to your cameras. Thank you so much. We meet in the next session in 2027. Thank you for your valuable presence. Thank you.
Thank you.
Stay safe. Thank you.
Thank you. Bye-bye.
Bye, sir. Thank you.
Thank you. Thank you. Bye.